I'm probably the only person that's ever said that to you, huh?
Yeah. Yeah.
Most people don't like them at all. What they really are is merely a test of your knowledge on trig identities.
Okay.
Okay? So, hold on. Let me get this right here. I want that on the left and that on the right. Okay, so secant cosine. That's supposed to equal 1. Can we make it equal
Yeah.
1?
Yeah. When we have to,
Well,
or I don't.
what's the secant equal to? What's its
Um.
what's its reciprocal?
Oh. Isn't this the reciprocal? Isn't that? Well, that's cosine, right?
Right. So this turns in to cosine over cosine, which is equal to 1.
Okay.
Okay? Let's review the 11 identities that you need to know. Okay? You don't have to memorize 11 things. Let's just talk about it real quick. We got
Okay.
sine, cosine, and tangent. There are 6 reciprocal identities. What's the reciprocal of tangent?
That's cotangent.
Okay? Means you only have to figure out one other. What's the reciprocal of sine?
That's cosecant.
And always remember that the first 2 letters are different.
Yeah.
Therefore, cosine is 1 over secant. So really, the only one you had to really memorize was the tangent. And that comes
Yeah.
real automatic. And then, of course,
Yeah.
the other 3 are cosecant, obviously, is the reciprocal of sine. And secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Okay?
Yeah.
So there's 6. I don't think you're going to have any trouble memorizing those, but you want to memorize them really well. They're used
Yeah.
frequently when you're doing verifies. Okay?
Okay.
Now, there's 2 quotient ones. Tan is equal to what in terms of a quotient?
Um, I wasn't too sure about. I'm not too sure on that.
Or cosine. Memorize that one. Definitely have to
Okay.
memorize that one. But
Okay.
the cotangent's pretty easy if you know the tangent. What's the cotangent got to be?
It's got to be cosine over sine, right?
Okay, so there's 2 more. There's only 3 more that you have to memorize, and you really only have to memorize 2 of these. And these are called the Pythagorean identities. And the number 1 they teach you is sine squared plus cosine squared. Now, obviously, I'm leaving off the x here, which you can't ever do. You know,
Yeah.
sine squared, in other words, it doesn't make any sense to have sine without an angle. Only reason
Okay.
I leave it off is because I don't want to rewrite it 11 times.
Okay.
Okay, what's this equal to?
Um, is that the tangent squared?
That's equal to 1.
Oh.
1 is a key number in all 3 of these Pythagorean identities.
Okay.
The second one, which you also have to remember, is tangents associated with secant squared. Notice the difference between the first one and the second one.
Yeah.
Okay? And the thing is that you have to know all alterations of these. In other words, you're going to be doing a verifying, and they're going to give you 1 minus cosine squared. They're not going to give you sine squared plus cosine squared usually. But
Okay.
you'll see this a lot, and you have to recognize that that's sine squared.
Okay.
Okay? And secant squared minus tangent squared is 1. So it's not just these that you have to memorize, it's also alterations of them.
Okay.
And the last one is the cofunctions of the second one. In other words, you have to
Okay.
memorize that, you have to memorize this, but there's a third one, and the cofunction, not the reciprocal, the cofunction of tangent is also cotangent. And the cofunction,
Okay.
what's the cofunction of secant?
Um,
Take the trig
is
function
that
and stick the words co in front of it. That's what cofunctions are. So
is that
cosecant.
cosine or okay cosecant?
Cosecant. In other words, the cofunction of sine is cosine. The cofunction of cosine is sine. The cofunction of tangent is cotangent. The cofunction of secant is cosecant. Those are your cofunctions. Now, in general, you don't have to really memorize your cofunctions in order to get through these verifying problems.
Okay.
But in terms of memorizing this third Pythagorean identity, it's helpful if you know that the third one is the same as the second one, only using the cofunctions instead of the tangent and secant. I'm going to use cotangent and cosecant.
Okay.
So there's 1, 2, 3, 4, 5, 6. 6
Yeah.
out of 11 that's all you have to memorize. Okay?
Okay.
But you have to do it. And what the purpose of these verifying problems is to get you to memorize. In other words, you do about 50 of these, and I guarantee you'll know all 11 of those perfect.
Okay.
Okay? So let's look at number 2. Tangent squared minus secant squared. Well, the original, let me pull up the Pythagorean theorem that we're talking about. It's this one right here, second one from the middle.
Yeah.
Tangent squared plus 1 equals secant squared. So,
Well, I guess
manipulate this one algebraically to look like the left side of this equation.
well, I guess you could for number 2 you could like add the secant to both sides and then
You're subtracting the secant from both sides.
oh, okay. Oh,
In other words, this turns in to tangent squared minus secant squared plus 1 equals 0, first of all. And now, if I move the plus 1 to the other side, that's what tangent squared minus secant squared is equal to, is minus 1.
okay.
Okay? And you get all of these by using these 11 key trig identities.
Okay.
Okay, so let's go down. I don't really want to erase those. All right, the next one we have, what's 1 minus cosine squared equal to? Excuse me.
Oh, is that sine?
What's the identity? What's the Pythagorean identity?
Well, it was that first one that we went over.
You got to memorize these. Okay, so sine squared plus cosine squared equals 1.
Yeah.
Therefore, what does 1 minus cosine squared equal?
It equals negative sine squared.
No. Just subtract cosine squared from both sides.
Oh, it's going to be sine squared.
Right. And then you're going to have sine squared divided by sine. That's equal to sine.
Okay.
Subtract the exponents. Okay?
Okay.
All right. Let's get as many of these done as we can here. So here we have cotangent And again, I leave off the variable just because you end up writing an awful lot on these. You don't want to do that on a test, incidentally. If you're answering these on a test, you want to put in the x. In other words, here, I'll do it properly. X there, X there, X there.
Okay.
Now, they say, well, sometimes the best thing to do on these is to convert everything to sines and cosines, especially if there are any sines and cosines on either side. Well, in this case, there really aren't, right?
Okay.
But what is secant? Well, hold on a second here. You know, that's not a bad thing to do here. What's the quotient identity for cotangent?
Isn't it cotangent of x equals cosine of x over sine of x?
There you go. So in place of cotangent, I'm going to write cosine of x over sine of x. And then what is the reciprocal identity for that? Because if I'm trying to put this all in sine and cosine, I don't want the quotient identity for secant. It doesn't have one, but use the reciprocal. What's its reciprocal?
Isn't it, isn't secant, isn't that 1 over cosine of x?
Good. Now the cosines cancel, and you're left with 1 over sine x. Well, what's 1 over sine x?
1 over sine x, that's cosecant of x, right?
There you go. In other words, I've duplicated on the left what I need to do. And that's exactly the way I usually do it. I work with one side only. I get down until the more complicated side agrees with the less complicated side. And then I'm done. Okay. All right. Again, let me just scroll down here so I can get back to my original identities. So on this one, we have cosine squared of x times secant squared of x minus 1. Well, whenever you see something like that, think Pythagorean identity. Okay. What's the Pythagorean identity for secant squared x minus 1? Remember, you're almost never going to see it in its original form. So far, 2 was not in its original form, 3 was not in its original form, 5 is not. So you always have to know those 3 Pythagorean identities in order to recognize what secant squared minus 1 is going to be. Okay. Remember what the identity was. Tangent squared plus 1 equals secant squared. So what's secant squared minus 1 equal to?
Isn't that equal to, that's going to be equal to tangent squared.
Right. So now we have cosine squared x, tangent squared x. And now, what's the quotient identity? In other words, I'm trying to prove that this is all equal to sine squared x, right?
Yeah.
Okay. What's the quotient identity for tangent?
Isn't it sine x over cosine of x?
So what's the quotient identity for tangent squared?
Sine squared x over cosine squared x, right?
Uh-huh.
So we just so we'll divide the cosine squared, or the cosine squared.
Cancel those, and you're left with sine squared. That's what we've been trying to prove. Okay?
Yeah.
So it's always using combinations of these 11 identities. Notice we had to use the Pythagorean identity to convert that to tangent, and then we had to use the quotient identity to convert that to sines and cosines.
Okay.
Now, part of the problem with these verifyings, if you get started off on the wrong foot, you can wander around for 20 minutes using identities and never get to where you're trying to get. So one of the reasons they say that if all else fails, turn stuff into sines and cosines. Well,
Okay.
that would have been a bad mistake on this one. In other words, once I'm looking at that secant squared minus 1, I got to turn that into tangent squared. Always look to turn two terms into one term. Okay?
Okay.
And then once I turn it into tangent squared, well, now I'm looking at a cosecant or a cosine squared there, a sine squared there. Clearly, I want to use the quotient identity
Okay.
to get rid of the cosines. In other words, it's okay to look on what's on the right side. It's kind of a map as to what direction you want to go. But try not to manipulate what's on the right side.
Okay.
Okay, number 6. Secant squared x minus 1 over sine squared of x has to all equal that. Well, what are you going to do there?
The Pythagorean identities.
So what can I replace that with?
You can replace it with tangent squared.
Okay, so now we got tangent squared over sine squared. We got to somehow turn that into secant squared. Well, again, we don't want to use the Pythagorean identity here. We just used it. So let's turn the tangent squared into using the quotient.
Okay.
So what can I rewrite that as?
You can write it as
That's the purpose of these exercises, is so that you'll memorize these. And trust me, you will. I don't know how many it'll take, but when you do a certain amount of them, all of a sudden it's locked into your memory.
Yeah.
And it's a beautiful thing that somebody came up with this game. That's all it is, because there's no practical real-world problems where you have to verify identities. There are practical real-world problems where you have to solve trig equations, and that also requires you to know your identities. But this is strictly an exercise to get you to memorize these 11 identities.
Okay.
Tangent
well, I guess
sine squared over cosine squared. Okay. Now I got sine squared over cosine squared divided by sine squared. What's that equal to?
That's equal to that's equal to tangent of x, right?
No, the tangent's gone. We got sine over cosine, both squared, all over sine. So this is what we got. How do you perform that operation?
Well,
you flip the bottom and multiply. In other words, never forget how to divide a fraction by a fraction. Now, the bottom doesn't look like a fraction, but it is. I can put a 1 under there, right?
Yeah.
And now flip and multiply, and you end up with 1 over cosine squared. In other words, the signs cancel.
Oh, yeah, the signs cancel. Okay.
And now what's 1 over cosine squared equal to?
That's equal to secant squared.
And then I draw a line up to that. We've proven it. Okay, and all of these are going to be identities. They're not going to give you one here that isn't an identity. So what they're teaching you to do here is prove identities. Now, if you really have a bad teacher, they may give you some identities on a multiple choice test, And believe it or not, it's the only kind of math problem I can think of where when you offer multiple choice, you make the problem 10 times harder.
Yeah. Well, we don't really have too many multiple choice like
Well, that's
tests
good.
anyway.
That's good when it comes to verifying trig identities
Yeah.
because you don't want multiple choice because
No, yeah.
then you have to prove that one is not equal to another, and that's
Yeah.
much harder. Okay, let's see. We did 6, right?
Yeah.
Okay, so let's look at 7. There's a couple of other techniques that are used when you're verifying identities. So far, I haven't seen any problems where we would have to use one of those more sophisticated techniques. The one thing you can't do is divide both sides by secant or divide both
Okay.
sides by tangent. In other words, you can't do normal algebraic processes. Not to say you can't manipulate both sides. That's actually allowed. But it's generally a better idea if you can take the more complicated side and make it look like the right side. And usually the
Okay.
more complicated side is always on your left, just like every problem here.
Okay.
Okay. Now, I don't see a lot of sines and cosines in this. I see none.
Yeah, I don't
I can convert that to sine, cosine, sine or cosine. I can convert that to sine or cosine, and I can convert that to sine and cosine. So that can't be a terrible way to go. Let's
Okay.
start on the left and convert everything to sines and cosines. Obviously, nothing's being squared, so I'm not looking at the Pythagorean identity. And I'm not really going to use the reciprocal identity for tangent because I'm trying to convert it into sines and cosines. So tell me,
So
yeah,
would we use the quotient?
right? So that one becomes sine over cosine. And what about the cosecant? What am I going to use?
Um, huh.
Convert it to sine or cosine?
Um, well, I guess we would convert it to sine, right?
Yep, it's 1 over sine. That cancels with that. And then what's 1 over cosine equal to?
1 over cosine is equal to that it's secant.
Okay. Yeah. You want to practice these till you get a little bit faster.
Yeah.
I think you got them down, but you're a little slow in accessing the memory.
Yeah, just kind of need
Well,
to keep
you'll
practicing.
get faster. I'm not worried about that because you're just starting. And
Yeah.
trig is always tough. It's almost like you're learning a foreign language, and at some point you think in the foreign language, but not for a real long time. You got to think
Yeah.
foreign language for a really long time before you can think in that foreign language.
Yeah.
All right. What am I going to do here?
Well, I guess we could use couldn't we use like quotient?
If I took the strategy of I'm going to convert everything to sines and cosines,
Okay.
that would
Well,
work. But gosh, I don't have any sines and cosines in here. In other words,
no.
there's fast ways to do these and there's slow ways.
Okay.
Any verifying problem, you can sometimes do it in 2 steps, and sometimes other people might take 6 steps to do the same thing. Well, the 6 steps
Okay.
count. You're not going to lose credit on the 6-step method, but obviously you want to learn to do it in the fastest possible way.
Okay.
Okay? So rather than turn everything into sines and cosines, this would be cosine over sine, that would be sine over cosine, and this would be cosine squared over sine squared. Rather than do that, I see a much simpler step. What's
What would we do?
what's tangent equal to?
Well, tangent is equal to sine of x over cos of x, or
That's one thing it's equal to. But what is it equal
or
to that we're looking at in this problem? We're not looking at
Uh,
sines and cosines. We're looking at cotangents. So what is tangent
well,
equal to relative to cotangent?
it would just be 1 over cotangent.
Okay, so let's hear. I'm going to write, there's the numerator. Here's my denominator. How do I solve this again?
Don't you, when you divide, you flip the bottoms, right?
Yes, you're almost never doing division. You're always flipping the bottom and multiplying. And
So would it be like
if I do
cotangent times?
cotangent times cotangent is cotangent
Yeah.
squared. Okay, so I've proven the problem with 2 steps. There was step 1, there was step 2. Okay,
Okay.
now I could get there with a lot more steps. Let's just look. Cotangent is cosine over sine.
Mm-hmm.
Tangent is sine over cosine. And now if I flip and multiply, I get cosine squared over sine squared,
Yeah.
which is fine because I recognize that as the quotient identity. So that'll be cotangent squared of x. But notice I've done 1, 2, 3 steps this time
Okay.
to prove it. So this was not the most efficient way to do it. So there's a certain art in doing these where you learn whether you want to do it. And one rule of thumb that I generally use is, gosh, if I'm like number 9, if I'm looking at a lot of, in fact, that's what's next, so let's do that. Okay.
Okay.
In this one, I'm seeing a lot of sines and cosines in the problem.
Yeah.
So that's the direction I'm going to go. Okay, and I got to prove that it's equal to sine of x. Well, the only thing I have to convert is the cotangent.
Yeah.
So, and I'm not going to use the reciprocal identity because that converts it to tangent. I don't need tangents. I want sines and cosines.
So it'd be cosine of x over sine of x.
And just be careful with your fraction bars here.
Okay.
In other words, make sure that the main fraction bar, the way I do it is always make it bigger. In other words, this fraction bar here is small because that whole thing is the numerator.
Okay.
Okay. Now, we've got, well, certainly I can cancel that sine of x with that exponent. You see that?
Oh, yeah.
Okay. And now I've got sine x times cosine x divided by cosine x. Well, I'm going to put a 1 under there, flip and multiply. That's going to take care of the cosine x.
Yeah.
So what I'm left with is sine x on the left.
Okay.
Okay. So, good timing.
Yeah.
Yeah,
Thanks.
but
yeah, I just kind of need to go over. I just kind of need to keep going over it.
You just, if you have,
memorize
the
it.
more you have to practice, especially of this nature, these are perfect because these are pretty easy here. None of these was more than 3 steps. I've seen trig verifies that are 12 steps. They're hard, and boy, you got to make sure you get off to the right start.
Okay.
These, just if you know those 11 that I pointed out in the beginning,
Yeah.
that's what these will lock into your memory. You'll know them better after you do. It'd be nice if you had 20 more of these to do, just like this. And let you do them. And because every time you do one, you're verifying your memory is what you're doing.
Yeah.
All right. Peyton,
All right, thank you.
I will
Yeah,
let you
appreciate
go,
it.
and I will talk to you tomorrow. I believe you have a session.
Yeah, yeah. Yeah, talk to you tomorrow.
Okay.
Bye.
Good one. Bye-bye.